All right, let's get started. Hi, everybody. My name is Patrick Chanezon, and today we have a university session on Docker nuts and bolts. So that will encompass, I got some questions on Twitter, that will encompass an introduction to Docker. So if you've been using Docker already, there will be a lot of introductory material, but I'll also show some more advanced stuff, including swarm mode, how to use Docker for development on a Mac for Java applications, a specific prototype that the team built recently that is not out yet of integration between Docker for Mac and Docker for AWS. I'll show you Docker for AWS, and we'll see how to build, ship, and run distributed applications. Okay, let's get started. Before we start, I'd like to know a little bit more about you, what you're interested in. So, who here has used Docker already? Okay, so a good half. So, who is using it in production already? Okay, a few of you. Yeah, that's a classic. Then, among the developers, who's a Java developer? Yeah, I guess a good majority. Any Node.js developers here? A few. Okay, Python maybe. All right. Okay, so that's a good mix. The talk is mostly focused on Java development, but the lessons can be applied to any language. Okay, so let's get started. So first, a little bit about myself. I'm French, as you can hear from my accent, but I live in the US. I spent 10 years in my career building platforms at Netscape and Sun, and then 10 years doing evangelism at Google, VMware, Microsoft, and I joined Docker a year and a half ago. While I was at Google and VMware, my last project at Google in developer relations was to create the developer relations team for Google App Engine and what became Google Cloud Platform. Then I left Google to join VMware, where I was in charge of Spring and Cloud Foundry developer relations. Then at Microsoft, I've done Azure and started to do Docker. And then at Docker, I'm working with Solomon on the future of the platform. What brought me to Docker is when I started using it, I was at Microsoft at that time, and the thing I was focused on is trying to get Java developers to try to move their workloads to Azure. And one of the ways was to use Azure websites at the time. I think it became Azure Sites now. It wasn't a great experience. It was very limited. Or you could use VMs. But then it was pretty painful, and you had to manage all that infrastructure. And when I saw Docker, I started using it to deploy these Java workloads on Azure, and that was a good mix. And when I started using Docker to build my applications, I just realized I had the same feeling as in 1995 when I started using the Netscape browser. And what I mean by that is that it was a new way of building my applications. In the same way as the Netscape browser, when I started using it, I realized at that time I was building client-server applications, and I realized, hey, we can build the apps on the server. They would spit out some HTML, and then everything would happen on the server, and it would be rendered on the client. And then after that, I spent like the next 15 years building that kind of web apps. Using Docker, I had the same kind of feeling. It's a tool that when you start using it, it changes the way you're building your apps, and it changes the way you're operating your apps as well. And so when I realized that, I just had a conversation with Solomon, and I joined these guys. Another note I wanted to have is for those of you who are old enough or who've been through several of these innovation cycles in technology, personally, I feel like that hamster in a training wheel. Every 10, 15 years, we have a big revolution that changes the architecture we're using. And one of the things that I remarked, I've been working for 20 years now, so I've seen at least 3 of these. what I remarked is that after a few times the same ideas are coming back again, maybe with bigger machines and bigger capacities, but the underlying ideas of how you architect your application just come back. So in the 60s, you had mainframe. It was everything on the server side, and your terminal was a VT100 dumb terminal. In the 80s, we had the client-server architecture where you would build rich client on Windows, and then you had an Oracle database and a vertically scalable server on the back end. In the 90s with the web, I think we came back to the mainframe era. If you think about it, the original browser was as dumb as a VT100 terminal, and everything was happening on the server side. And right now, what's happening with cloud and mobile is that both the browsers are becoming smarter, and mobile operating systems have as much capacity as the client-server operating systems from the 80s. And then everything is happening on the cloud for the server side, but on the server side, it's horizontally scalable distributed architectures. So let's talk about why Docker has been successful, and that's one explanation that I have with where that's my analysis, my personal analysis of the market, and why I think Docker was successful, and I'm using movie metaphors for the different players. So on the left, you have private cloud, and that's where, or when I say private cloud, the data center, that's where people were running their workloads. And right now, the big challenge in the past 5 years is that big move from data center to what people call either private cloud, hybrid clouds, or starting to use public clouds. And so that migration from the data center to public clouds, there's 3 big providers of public cloud, Amazon, Google, and Microsoft. And then in the data center, VMware rules over there with their virtualization technology. And so the way I compare the strategies of these different players is through movies. So to me, VMware is like the movie 300. I don't know if you saw that movie. It's a pretty cheesy movie, but it's fun to watch. It's about 300 Spartans who resist an army of 100,000 Persians, and they're very courageous. They shout in battles, they shout Sparta, they're very strong, and they resist very valiantly, but at the end they all die. So to me, that's how I see VMware. They're trying to resist in the data center market. Right now, recently, actually, they reached a truce by doing a deal with Amazon, and I think that's maybe one way for them to prolong the time that they can milk their cow. So then you have Amazon Web Services. They created the public cloud market in 2006 with EC2. And to me, I would compare them to Independence Day 2. I don't know if you saw that movie. It's very bad. But there's one hilarious scene where a spaceship the size of the Atlantic lands on Earth. And there's one general in that scene who says, who calls the president. He says, "Oh, they landed in the Atlantic," and he says, "Where?" And he says, "All of it." And so the spaceship is as large as the Atlantic, and that's pretty much the effect that Amazon has on its competitors who are selling software in the data center. Like they have a scale effect. And it's really hard to reach. Gartner even had to resize their Magic Quadrant, I think, a year ago, because they were so much bigger than all their competitors. Then you have the Google Cloud Platform, and to me, it's back to the future. So the Google Cloud Platform, while I was at Google, I tried to sell Google App Engine, which was a platform as a service, only hosted to enterprises. We did a version that was called Google App Engine for Business. And after I presented them the offer, you just code, you do your code, you push it to the platform, we take care of everything, and all the data is in the Google data center. People just laughed at me. They told me, just come back when you have something we can use, because we want to do private, we want to do hybrid, and we certainly don't want all our data to be in Google data centers. And so App Engine had a really hard time catching up, especially in the enterprise. And to me, I felt like Marty McFly, the hero in Back to the Future, where he's from the 80s, he comes back to the future in the 50s, and he starts playing rock and roll, and they don't know rock and roll yet, but they love it because they were ready for it. But then at the end of the song, he starts exciting himself, and he plays hard rock, and there's a big silence because people don't understand that music from the future. So to me, that's really the Google story, where their technologies are always ahead of time. And if you're looking at things like BigQuery, for example, it's a great example, or Spanner, which is not even productized yet. They have very advanced technologies, but they don't know how to provide a story of migration to users from where they are to where the future is leading. Microsoft, to me, has a pretty good strategy where they really bet on hybrid from the beginning, with Azure on one side and Azure Stack on the other. So they're catching up to Amazon with Azure, and then they have Azure Stack that's a pretty good play for inside the firewall using the same APIs. So I compare them to Terminator 2. So in Terminator 2, Schwarzenegger comes back, but this time he's the good guy. And then in the middle of that, you have a transformation. So developers are more interested in public clouds, and ops traditionally have been focused on the data center. Right now, they're converging in the middle in a cultural movement that's called DevOps. And I'd say Docker, one of the reasons why Docker was so successful when it was introduced 3 years ago, is that it corresponded to the time when enterprises started to migrate workloads from private cloud or from data centers to the public cloud. And Docker provides that isolation layer where they can run the same workloads on any cloud independently of the underlying infrastructure. So what the new stack looks like in that context is something like this. At the bottom, you have either your cloud or virtualization provider who provides infrastructure for compute, networking, and storage. So here you have VMware, Azure, Amazon, Google, and others, but these are the 4 big ones. Then on top of it, you have the operating system. And what happened since Docker was introduced 3 years ago was a dramatic transformation of the operating system. Basically, the operating system shrunk to become just a kernel with a Docker engine. And then everything that your app needs, all the dependencies get put into what is called a container image. So CoreOS started this trend with their reduced operating system. And then very quickly, Red Hat followed suit with Atomic, then Ubuntu with Ubuntu Core, and then VMware with Photon. And what's really interesting is in that process, even Microsoft, who adopted Docker and implemented it in Windows Server 2016, created a version of Windows Server 2016 called Nano Server that doesn't have any UI, that's much smaller, and that's just a small kernel that you administer using PowerShell. That is designed for the data center to have higher density of workloads in the data center. Then on top of that, you have Docker. So Docker, the engine and the platform. On the left, you have all the plugins. So at Docker, one of our philosophies is batteries included, but removable or swappable. So that means for certain aspects, you can plug a different component. For example, for volumes, you can plug GlusterFS or Flocker. For networking, you can plug Weave, Calico, Midokura, Cisco. There's a whole ecosystem of plugins out there. And then on the right, you have orchestration, and this has been where the battleground has been over the past year. So there's lots of different orchestrators for containers. I'd say today the three big ones are Swarm, or actually Docker itself, because since 1.12, since last summer, Docker has orchestration built in. It's called Swarm mode. Kubernetes by Google, which is an open source project, and Mesos, the Apache Mesos project. So why is Docker important? One aspect of Docker is that it enables teams of developers to become more agile. As developers, we love to build complexity. We're always late. And extreme programming, which evolved into different agile methodologies, appeared in 1999. I remember introducing that to my team at Sun back in the days, maybe in 2000. Right now, every enterprises are using Agile, and they're not using it because it's cool for developers. They're using it because it's good for business. And Adrian Cockcroft, who joined Amazon recently and was at Netflix before, coined a term that I like a lot that summarizes what Agile is about. It's to lower what he called the MTBAMSH, the mean time between ID and making stuff happen. So agility is really about dollars and about business. It's about developers focusing on building business value faster. The other trend that happened in the past few years is DevOps. So since the mainframe era, devs and ops were in separate teams that didn't talk together and often had different cultures and values. In the client-server era, it wasn't much better. I remember at Netscape, we were coding in C++ and Java, and the ops were coding in Perl, and they didn't understand the workloads that we asked them to run. In the web era, it wasn't much better. And then what happened when public cloud infrastructure appeared, this cultural movement appeared that was called DevOps, where devs and ops are working together using the same tools and trying to have similar values. So DevOps is a cultural movement. To me, it's a prolongation of what Agile is about, but including the ops teams. It's not only about tools, it's mostly about people and processes. So when people want to introduce a DevOps approach in their company, one of the first things to look at is training people, maybe reorganizing the teams in a different way, and then introducing practices like continuous delivery, infrastructure as code, collaboration among silos, and doing small iteration in order to have a feedback loop and measure everything. So as Agile, DevOps is really about business, and the rationale is here. In 1999, if you were a Windows sysadmin, you would manage 5 servers. If you were a Linux sysadmin, you would manage 50 because Linux is much more easy to automate. In 2015, it's more like 10 to 20,000 servers. And here I'm talking about large companies like Google and Facebook where everything is automated. So there's a factor of 2,000 here. So when sysadmins are managing more servers, what that means is that the infrastructure management needs to be completely automated and rethought. So again, I was talking about the people and processes as well as products. Henk Kolk, who was director of IT at ING, gave a very good talk at DockerCon in 2014. I highly advise you to watch it, where he talked about their adoption of DevOps and how they became more agile and how, especially the organizational aspect. Basically, they started with a big reorg and they mandated that everybody becomes a developer and know how to code. So let's talk about the Docker platform. So at Docker, our goal is to build what we call tools of mass innovation. That means finding technologies that help people innovate with a mass aspect. And one of the tools that we think will create the most innovation with what's happening right now is the internet, being able to program internet devices. And so in order to do that, we're building our product as a stack. So at the bottom, it's built on standards. What I mean by that is, I think it was 2 years ago at DockerCon, with 40 different other companies, we created something called OCI, the Open Container Initiative. That's a standard for container runtime and image format. I think Phil Estes, who's here, has a talk about that later during the conference. And so OCI has a reference implementation that's called runC, and runC is at the heart of how containers are run in Docker. That's the reference implementation of the spec, and that's the piece of code that runs container inside of Docker. Then on top of that, this is built on infrastructure. So runC will be part of that, and a series of libraries. Docker started as a product, like a fully finished platform product with a UI that's pretty opinionated. And along the way, along the years, we split out different infrastructure components, things like runC or containerd or InfraKit. I'll tell you more about these ones. So there's lots of development in this area. In the past year and a half, we open sourced a lot of that. And these components allow you, if you don't like the opinions of Docker on how the UI should be done, to just use some of the infra component in order to create your container infrastructure. Then on top of that, we built a development platform. So that's Docker. And on top of Docker, we build commercial products. So we have a Docker Trusted Registry and Docker Universal Control Plane, the two former product that's called Docker Data Center, and that's what we are selling to enterprises to manage what we call a container as a service delivery chain. So what is Docker? Docker is essentially built around Linux kernel isolation features, namespaces and C groups. So it started with Linux, but now Docker runs also on Windows, and in order to create the Windows port, the Microsoft team contributed in two areas. One area is they had similar isolation features in private builds of Windows kernel that were used by the Bing team to run the Bing cloud platform. And so what they did is that they took these isolation features and put them into their commercial version, which is Windows Server 2016. I think it shipped last month, so in October. They announced it at Ignite. And so in Windows Server 2016, they put the right isolation features. And then in the Docker open source project, they created a new backend for Docker to use the Windows kernel isolation features and an image format that they built for Windows images, which allows Docker now to run both on Windows and Linux. The other aspect of Docker that's important that made it very successful is this notion of image file system with a union file system plus a copy and write layer at the top. So essentially, when you're building your images, you're layering a series of images. Like, for example, I would use an Ubuntu base. So I have an Ubuntu image. On top of that, I can add one file, and that will create a new layer. And then when I run a container, Docker is going to create a writable layer on top of that. That makes it super efficient for deployments. When you deploy an image, if you have the cache of, for example, if you have 15 different applications that are slightly different but all run on Ubuntu, Ubuntu will be downloaded only once. So it makes running containers much faster in development as well as in production. And that's a big difference with virtual machines, where I remember a period when I was working a lot at Microsoft with virtual machines in Azure. Every time I would create a new one, it was 4 GB to upload to a blob somewhere before making it useful. So Docker for developers, it's pretty simple. You start by creating what is called a Docker file. So a Docker file lets you inherit from an existing image. So we have a Docker Hub, which is a repository of images. So you look in there for a base image to use, or you can create your own that all your developers are going to use. Images are versions with what is called tags. So here I'm inheriting. So here I'm working on a Java application, so I'm inheriting from the Java image in version 7, but I could use version 8. Then you have a series of directives. So here I have a copy directive that's going to copy all my source code inside of a directory inside of the image. Then I specify a working directory inside of my image, and then I can run commands. So here I'm just compiling my Java code with Java-C. So that's a very naive example. I'll show you some more useful ones. And then I can run a command. Here, Java main. So that's a command that's going to be run when I run my container. So once I have built that Docker file, I can go on the command line and do a building that image. So in order to build, I do docker build. With -t, I can specify some tags, and dot means in the current directory. So that means that when I do a copy of dot, it's a copy of what's in my current directory that's going to go into the image. So when I do that, Docker builds the image. Eventually, I can push it to Docker Hub or to a private registry. And then after that, I can run my container. Here, -it to get a terminal, -rm to destroy the container when it's done. I can give it a name and then the name of the image. One of the things is, so you're building your code, you can choose to use the container, you can build your image so that the image builds your code, or another best practice that people have been doing is using a container to build your code, and then after that you build the image with the artifacts, so that you don't have a lot of layers that are useless in production. So an example of doing that is here I'm using the so here it's a kind of it's a simple example using Java-C. So here I'm going to build so here I'm doing a Docker run. With -v, I mount a volume from the current directory inside of a container. Here I use a Java 7 container, and I do a Java-C that's going to create a class file. And then after that, I can build my image by just copying the class file instead of having to compile it inside of the image. Very often, personally, I'm using the Maven image to build my projects. I'll show you how to do that. So actually that's the command I'm using usually. When I have a new Java project, instead of, I used to have Maven installed on my laptop. I think I still have it, but I don't use it very often. Now I'm using a Maven image here, so Maven 3, with a GDK 8. And what I do is I do a Docker run. Actually, that command is not the best. Usually, it's better to mount to create a volume for Maven. So here, I'm mounting the .m2, my Maven local cache inside of the Maven container. A best practice, instead of doing that, is to mount to create. You do a Docker create volume, Docker volume create Maven. And then you mount the volume so that all your builds always have a Maven volume to reuse the cache. And then here I mount my source code into user source, and then I do a Maven install inside of that. So if you want to, let's take an example. So to analyze images, you can do Docker images. Let me make that bigger. So if you do a Docker images, it will show you all the images that you have on your system. So you can see I have a certain number of them. If I do a Docker images Java, it's going to show me the two Java images I have. I have OpenJDK and Java 8. And then if I if I want more details about one image, I can do a Docker history of Java 8. And it will tell me all the layers that have been created on that image with some details about their size. Here you can see I'm setting some certificates, or that's in the official image. It's setting the version. It's running. It's installing some packages and things like that. When you want to know more, one of the things I advise you to do is just go to Docker Hub. So you go to hub.docker.com, and there you search for Java. So before using an image, even an official image, I like to know where, I like to know how they're built, how they're structured, what's inside. So here I go to Java official. So this one is it's deprecated. Oh, we should use the OpenJDK image. Okay. So OpenJDK image. If you go in there, you see all the tags that they have for versions of Java 6, 7, 8. Oh, there's even a 9 image. So that's one of the benefits of Docker. You can try different projects with different versions of Java without having to install all that stuff on your laptop. So they explain you how to use this image. So here, inheriting it from OpenJDK. And then they explain you all the variants. There's one variant that's called Alpine. So Alpine is a very small distribution, Linux distribution, that's using a different glibc. It's called Muscle. A different libc implementation called Muscle C. And it's a very small image. So usually Alpine images are much smaller than the other ones. And then what I like to do when I'm using an image is just to see what the Docker file looks like. So usually it's linked from the official image. And then you can see what they're doing in there. So it's inheriting from a Jessie image, and they're installing a few packages to unzip stuff. And then they're installing Java in there, or the OpenJDK, and set a few environment variables, and that's kind of it. But when you're using some images that you find on the hub, it's often useful to go in the Docker file and see how it's built and what you can do with it. So how to build an image. So here is an example of a Docker file for an application that I'm going to show you. So this application, it's a Spring Boot application that's using MongoDB as a backend. And what the application is doing is it has a web front end with a nice Ajax front end where you can drag and drop images. And it will take the image, pass it to a REST service that's going to add some annotations on top of the image, and then store it in MongoDB using MongoFS and Spring Data. So that's kind of it's an example from Josh Long that I really like. It demos really well, and it shows kind of everything, or a lot of the things that you can do with Spring Boot, and it was very easy to Dockerize. So here I'm inheriting from Java 8. I specify who the maintainer is. I expose port 8080, so that's exposing the internal port to the outside. So when I do a Docker run, I'll be able, with -p, to override the port to map it to a different port on the host machine. Then here I have compiled my jar already. So I have used a Maven container to compile my jar. So I just copy the jar inside of the container in a specific location. I switch to that working directory. And then my command when I do a Docker run of that container is Java. I pass the port that I expose, and then I pass the MongoDB URI that I need to pass as an environment variable. and then -jar with the Spring Doge.jar. So Spring Boot applications bring the web server within them. So if I run that, that should just work. In order to build my image, I do a Docker build and I call it something, and I specify dot, which is the current directory. So that's how to build an image. And then to run a container, if I want to run that container by itself, I need to have MongoDB running somewhere. And here, I suppose that the host where I have run MongoDB is called Mongo. So I pass that MongoDB URI. I map 8090 to 8080. And that's it. That should just run my service. Now, installing MongoDB on my laptop, that's kind of painful. And like doing a mapping with a host name, that's difficult. So that's what Docker Compose is made for. So Docker Compose allows you to run multi-container applications. So here, in that case, we're going to run the previous app, but as a Docker Compose file. So you create a YAML file. Here, I'm using version 2 of the Compose format. I define a set of services. So here, I have web and Mongo. For web, I specify the image that I want to run. This is the image that we just built before. The port mapping, I can create some links. So links between services. So here, I'm going to create a link from the web service to the Mongo service. So links themselves are kind of the old way of doing things. The more modern way is to use networks. You can have a network section in there where you specify all the parameters for the network driver that you want to use. And you can put your web and Mongo services into different networks. Or in the same networks, but each service can be in several different networks. And when you're using networks, the service name is what is used as a host name for the service, and then load balancing is done by the application, by Docker, I mean. So here I specify Mongo as the link, and that's the name Mongo that I have there, which corresponds to my second service. And here I just pass the name of the image, and it's going to start a Mongo database. Okay, so let's show you what it looks like. So here, so all the stuff I'm showing you is part of a repository that I have on GitHub that's called Docker Tips. So the source code for all this and the instructions is in there. The Spring Doge workspace is in there. So with all the instructions for it. There's one last aspect. In order to develop my app, I would need to install Spring Tool Suite. So if I'm a developer and I join that team, I'm going to have to read a long README that explains, oh, please install Maven, and then install Docker, install Spring Tool Suite, create your project, install Mongo, set up your debugging in Eclipse, and so there's a lot of things that you need to do, and very often developers take a few days in order to start doing their first pull request in a project. What I've done there is I went with the full automation where, actually let me show you the project itself. All right. Okay. So what you can see there is I have So I have created this Docker Compose file. And what it's doing is it's doing a few things. First, I still have the Mongo image in there that I'm running. But there you can see something different. Here I'm running a container that's called STS. Basically, I took the latest Spring Tool Suite, put that into a container, and then I'm running that container. I'm running the IDE inside of a container, and I'm passing to it the display variable here is the IP address of an X server that I'm running on my Mac. So here on my Mac, I have an X server that's called X Quartz. No, so I don't want to run that. So X Quartz is running X applications here on my Mac. And inside of the container, I pass to it the IP address of the Mac as viewed as inside the container. Actually, let me show you what the how and all that all these steps are documented on my GitHub repo. I think it's display Mac. So that's a little command that gives you the IP address of the Mac as viewed from inside of the container. Then I add colon 0 to that. And I have a little bash function called startx that checks that X Quartz is set. And that's it. So once I've done that, so I pass to it that display Mac environment variable. Actually, let me show you what it is. So if I do echo of that, this is the display that I pass in there. The MongoDB URL here is Mongo because that's the name of the service here and the link. And I expose on port 8080. Here I have created a volume called Maven. So if I do a docker volume ls, you see I have a Maven volume and it has all my Maven cache in it for all the applications that I'm working on. And then that's it. So the other thing that I've done is, as part of the project, I checked in the Eclipse configuration for debugging, which means that now when I do a Docker compose up, it's going to start the Eclipse. Okay, so I have a port already allocated. So let me do a Docker PS. I'm running lots of stuff in there. Oh, it's C advisor. So maybe I just or what I could do, I could just change the port. I'm just going to expose 8090. All right. So here I'm. So on one side, it's running Mongo inside of a container, so I don't need to install it on my machine. On the other side, it's starting Eclipse inside of a container as well and sending the display to the Mac. And there's a problem with the display. Okay, so that's a pretty nasty demo effect. So let me see if I have the right preferences there. Okay. I think it's on security. No, so that sounds correct. It's kind of weird. Okay. So I'm just removing everything. I'm going to do startx again. Oh, maybe I'm going to kill this guy and restart it. Okay. Oops. And now let's try a Docker compose up again. Okay, so it's starting Mongo, then it's starting the IDE. And one of the, so here what I'm showing you is kind of going all in on Docker, where you have both your code in Docker, your IDE in Docker, your databases, you put everything in there. But you're not obliged to do that. One of the benefits of Docker is that you can really choose and mix and match. You could use Docker only to compile your application and then use it with a regular IDE on your computer. Or you could decide to use Docker to compile it, but also to create images for the final application, or use it only in testing, or have Docker only used by the CI/CD system and then the production system. You really choose where, at which level you want to use it. So here I have a problem with the display. I'm not sure. Okay, so maybe I won't show you that demo. I don't know what's wrong there. Okay. Yeah, I'm not sure. Yeah, this guy seems to be open and has the right preferences. Yeah. Oh, maybe I can use a different method. So there are different methods to expose. So if you go to Docker tips, I have a whole cheat sheet of how to run these graphical apps in Docker for Mac. One of the ways is to do to use SOCAT. So maybe I'll just do that. Yeah, that. Okay, so that should work too. Oh yeah, Docker Compose down. Oh no. Okay, so I just won't show you the X11 demo today, I think. So that's one. Yeah, so that's one of the things I wanted to talk about. So the first part is how to use Docker in development. Then the second part, I wanted to tell you about what's new in Docker, all the stuff that we announced in the past 6 months. So there's been lots of news. In terms of developer experience, so we think the best tools get out of the way and adapt to you and make the powerful simple. So what that means is we implemented that in the form of Docker for Mac and Docker for Windows. What I've been using up to now is Docker for Mac. And the way it works is you just install it from Docker. Once you install it, it uses or it installs that little whale here that shows me that Docker is running. I can check which version I have, and then I can set some preferences. For example, I can change the memory that my Docker VM is using, the number of CPUs, and there are some advanced preferences to use registries or to set proxy settings. There are some preferences for file sharing, for privacy, and I can reset it from there. And so what it's doing is, under the hood, it's using it's called Hypervisor Framework. There's a new framework in Mac OS X since 2 versions that lets you create your own VM. So Docker for Mac doesn't use VirtualBox anymore. It creates its own VM with an Alpine image in it and Docker installed in it, and a series of 2 drivers, one for networking and one for volume, that translate the system calls between Linux and the Mac. So for the networking, in there they're using the I think the TCP/IP stack of Mirage OS, the unikernel project, in order to translate all the calls that are coming out of the VM. to make the Mac believe that they are coming from itself, and that allows Docker for Mac to work well with proxies and VPN. The other thing is when you're mounting a volume, they did a file system driver that is pretty efficient, and that is much more efficient than VirtualBox shared folders in order to access the files on your Macs. So that's Docker for Mac. The other thing is in orchestration. So in 1.12 last summer, we announced that Docker 1.12 now has orchestration built in. It's called Swarm Mode. So there's a new API that's called the Service API. So in order to create a service, you do a Docker service create. And what this will do, it's a declarative API. You declare the state that you want your service to be in, and the orchestrator is going to reconcile that state across the cluster. There's a cryptographic node identity, which means that by default, when you install a swarm, it's going to generate some certificates and regenerate them, and you can specify the time by which the time of refresh. The refresh time for your certificate, so you can go down to 5 minutes. I think Diogo does that in his demos. In prod, you would use a longer time. But let's just say that each node has its own certificates and it's TLS enabled from end to end. And there's a built-in routing mesh, which means that when you're scheduling a container inside of a Swarm cluster, it's going to if you publish a port, it's going to open that port on each of the nodes in the cluster, and then you can go on whatever node you want in the cluster. It's going to load balance and reroute your traffic to the right containers on the different hosts. And then you can plug an additional load balancer for HTTP load balancing in front of that. So if you have Docker for Mac or Windows, you have Swarm mode in there, but you need to enable it. So it's an optional feature. To enable it, you do a Docker Swarm init, and then you can start doing a Docker service create. So for example, if I do a Docker node ls here, you can see that I have a swarm on my local machine. The host name is called Moby. It's ready, and it's the leader because there's only one node in that swarm. So that's what was introduced at DockerCon. Now, in terms of ops experience, ops very often want to deploy on certain cloud platforms. So Amazon and Azure are the two most popular ones. So we created Docker for Amazon and Docker for Azure. They're beta, but they used to be private beta. They are open beta now, so you can play with that today. And what these are fully featured installation of Docker Swarm cluster on Amazon and Azure that deeply leverages the underlying platform. So there's a deep integration with the native load balancer, the template language, either CloudFormation or Azure Resource Manager template. The SSH keys that you may have there, access control, scaling groups, firewalls, etc. And I'll show you how that works. And then the last thing that we introduced last summer was an experimental format that's called the Distributed Application Bundle. So I showed you my Docker compose file here. When you're building a compose file for production, typically there's many more environment variables and things that are non-portable in there. The DAB file is supposed to be the portable part of your application that specifies the images with the SHA of the images, the port that you want to expose inside of the container and things like that. It's still experimental. There's a support for it in Docker Compose, so you can do a Docker Compose bundle, and it will generate a DAB file from your Compose file. And if you do a Docker deploy of your DAB file to a cluster, it will just create the services for you. Before I go to Docker CAS, I wanted to show you the kind of integrated experience that we are shooting for at Docker right now. So let's first run our Spring Doge application there locally first. So oh yeah, I wanted to show you the compose. So that's a compose file I'm using for development, but I have one that I'm using for running the app. And this one is a simpler one. I just run the Spring Doge container. I'm going to map 8090 there. I link to Mongo, and I pass the MongoDB URI as an environment variable. So I save that. So it's called Docker Compose Run. So if I do a Docker Compose -f Docker, oops, Docker Compose .run .yaml. So, oops. Oh yeah, I want to go up. So here, what it's doing is that it's creating a network by default. If I'm targeting a swarm cluster, it's going to create an overlay network between the different nodes. And then it's starting Mongo and my application. And the beauty of Docker for Mac is that it's really integrated even at the network layer. So if I do a localhost 89, so now it's going to be exposed on localhost once it's running. So let's try that. Oh, it works. Okay. So what the application is doing is I can take an image there. I don't know, have a screenshot. So I paste an image to Dogify, and it just creates, it adds a bunch of gobbledygook on top of it. So that works. Now I want to run that on a cluster, and to show you the kind of integrated experience we're trying to build. What I show you here is a prototype. It's not out there yet. It's a prototype that we built for LinuxCon recently to show where the experience with Docker is going. So I don't know what form it will take in its final form when it finally ships. It's an integration between Docker and Docker for Mac and Docker for AWS. So if I use Docker Hub, I have what we call a Docker ID in there that I can use on Hub or on cloud. So if I go to hub.docker.com, you would see that I'm logged in there, and that login is called a Docker ID and gives me access to Docker Cloud as well. So that login, let me see. If I go there, if I go to account settings, in there I can create an API key. So I have created an API key. And I copied it. And once I've done that, here I can log in with my Docker ID. So here you can see I'm logged in Docker for Mac. And here there are two new menus, My Swarm and Create Swarm. So here I can say, I want to create a swarm on AWS. And what it's going to do is it's going to redirect me to Amazon Web Services with the CloudFormation template for Docker for AWS. And so here I'm using the native UI of AWS. So my stack is going to be called Pat Docker DevOps 2. I can specify how many managers I want. So here it's not production. I'm going to put only one, maybe 2 nodes. The size that I want. Here you can see the integration. I can specify the SSH keys that I'm using usually. So they're there. And there, this is the new part of the template, which is the swarm name. So here I can specify a name in my namespace, in the Chanezon namespace on Docker Cloud for how I want it to be presented in the UI. So I want that to be called DevOps1. My Docker ID is there. My API key, I forgot where. Yeah, it's there. All right. And then I click next. So here I can specify like key value tags that I want for my instances that I can use for orchestration constraints. And some other options. I'm just not going to do any of them. And then I create. So then it's going to use that CloudFormation template to create a cluster with the machine with the sizes that I want. It's an Alpine image in there. It has Docker installed. It's going to create a swarm, a secured swarm that's running in Amazon, and it's going to create a load balancer, and it's going to launch some containers as global services that listen to swarm events. And every time I create a service and I publish a port, it's going to publish it, open it on the load balancer. So it's going to auto-configure the load balancer for me. So here I have provision 1 before. So it gives me all the instructions to connect to a cluster. Oops. But here, that's the new menu. Now that I have connected my Docker for AWS instance with Docker Cloud, what it did is that when it has finished provisioning it, normally to use that swarm cluster, I would run a tunnel. So I could connect to it, I could SSH to it, I could create a SSH tunnel to it and then use my client to talk to it. To make that easier, now I can just go there, my swarm, Chanezon DevOps, and what the template has done is that at the end of the provisioning, it has registered its keys with Docker Cloud associated to my Docker ID, and now it just appears in my menu here, my swarms. And you'll see the DevOps 1 cluster when it's finished completing. So this one, that's the one I was deploying before I started the talk. So here when I go there, it's going to open a terminal and have the tunnel already established to the swarm. Yeah. It may take a while the first time. Okay, so here I have a terminal that is connected to my DevOps, cluster. So if I do a docker node ls, you can see that I'm talking to a Docker for AWS cluster with, here I have 4 nodes. Let me make that bigger. Yeah, I have 3 workers and one leader in there. And if I do a Docker service ls, service ls, you can see that the services that are running already on my cluster. So the cloud server proxy is the only one. If I do a Docker ps, I should be able to see all the containers running on that cluster. So now that I'm there, I can go to, actually let me go to Docker tips. I'm just going to take this guy. Oops. So I'm just going to go to that directory. So this is the directory where I have my code and my compose files. And I can just run, and then I can run, so this is swarm mode. So in swarm mode, I cannot use, compose and swarm mode are not compatible. Compose works with swarm 1, not with Docker 1.12 and swarm mode. The team is working on it to try to remediate to that in 1.13. But so in Docker 1.12, you either use Docker service create, and you could create services manually, or you use a DAB file. So in order to create a DAB file, I just take my run file there, and I do a Docker compose bundle, and it will generate this. And here it defines my Mongo service and my web service, defines the environment variable, the network, and then the SHA of the images and the ports that need to be exposed. So if I want to run that on that cluster, I need to pull the images first on it. So I'm just going to do that. So that's happening on Amazon. One of the so I'm just going to pull all these images, and then I'm going to do a Docker deploy, and that will deploy my DAB file to that cluster. One of the things that still doesn't work is the DAB file doesn't know about the port exposition, about publishing external ports. It knows which port to map, but it doesn't know about publishing ports. So once you have deployed the DAB file, for the ports you want to expose to the outside through the load balancer, you need to do a Docker service update and publish the port. So I'm just going to, so either you use a DAB file and you do that trick by doing a Docker service update, or the other option is to just use the Docker service API. I'm just going to pull Mongo as well. And while it's pulling, I'm just going to show you what the commands look like. So this one is Prometheus. Yeah. I thought I had them somewhere in there. Oh, actually, while it's pulling, I'm just going to show you a Docker service command. So I'm just going to go there again. I'm going to say, open me another terminal to that swarm. Oh, you see my DevOps 1 swarm is up. So I'm just going to keep on the DevOps swarm. And in there, I'm going to do a Docker service create. So here I'm going to show you a demo container. That's Evan Hazlitt demo. This one is interesting because it shows you the load balancing in action. I'm going to ask for 10 replicas. I'm going to call it demo 1, and I'm going to publish port or 8080 would be fine. All right. So if I do a Docker service ls, it should show the service with the number of tasks. You can see here, demo 1, it has 10 tasks up out of 10. Docker, if I do a Docker service inspect of demo 1, you can see there I have some more details about the service that I created, the container spec with the image, the number of replicas, the target port and the publish port. So here you can see I published the port 8080. And when I do that, that will cause Amazon or the container inside of Docker for AWS to expose that port on the external load balancer. So here I need to go back to my stacks there, and I think it was Pet Swarm DevOps, the one that I created before. When I go to the output, it's going to give me the DNS target name. So that's the target name for the load balancer. So if I go there on port 8080, it should be running. I think I had exposed 8080, yeah? Oh yeah, here you go. So that's the Evan Hazlitt container. So what you see there, what this application is doing, it's a simple web application that does XML HTTP request calls back to itself. and shows you the name of the container that is responding to just show how load balancing works. So here you can see I see at least like 2 containers who are responding out of the 10 replicas that I have in there. So I'm just going to let it run, and you'll see at the end it should go to more than 2 of them. So now that I showed that this stuff is working, so it seems that it has some trouble pulling Mongo. Oh, that's weird. Oh no, okay, so it's pulling Mongo. Maybe I'll modify my dab file. Where is it? Oh yeah, the dab. Oh no, 1880, that should work. I'm just going to publish it on a different port. So once I've done that, I can do a Docker deploy of Spring Doge. I think that's the name of my dab file. Yeah. So here it's loading my bundle, and it's going to do a Docker service create for the 2 services. It creates a network as well. So now when I do a Docker service ls, I see that I have a Mongo service, Spring Doge Mongo, and Spring Doge Web here that is still starting. Oh, maybe I'll do Docker service ls of the web one. Oh no, it's not Docker service ls. Okay. All right, so it has a target port of 8080 and a publish port of 30,000. So what I want to do there is instead I want to expose like 8081 or something like that. So that's where I need to do a publish add. So here I'm doing a Docker service update. So I'm updating the Spring Doge web service to change the publish port to 8090. Docker service ls. Okay, so my web task seems to be started. One of the other thing I wanted to show you is when I say deeply integrated with AWS, you saw it's integrated with my SSH keys. It's also integrated with CloudWatch. So when I'm running Docker for AWS, all the logs are going in CloudWatch. So let's take a look at the okay. So I want the logs there. Oh, not in, yeah, I see. Okay, so not in that version, actually. The CloudWatch integration is more recent than that. The template I've been using there is one from last month. This is one that I deployed with the latest beta that you can find on the on the beta page. If you go to beta.docker.com/docs. So if you go there, Docker for AWS release notes. There you see all the latest versions. So this one is from last week, and this is when you do launch stack, you're going to go to AWS. So the stack that I launched with the cloud integration is like 1 month old, and it doesn't have the CloudWatch integration yet. But this one has it, and I can show you some logs of a Java application that I've run before, just to show you what it looks like. Yeah, okay, so it looks something like that. So there, basically, you get all your logs, but in Amazon. Yeah, so let's try to see if it's. Let's try to see if it's. So I go back to CloudFormation. I was talking to the Pat DevOps. When I go to the output of the template, it's going to give me the default DNS target. I'm just going to use that again. And I published it, I think, on port 8090. All right, so my app is running now. And now from using the... So let's try if it's actually working, if it's well connected to MongoDB, and if it can process images. Okay, that works. All right. I don't remember. I think it's a Docker service scale. Let's scale the Spring Doge web. I don't remember the syntax. Maybe like that. Yeah, that works. So now I'm scaling my service, and I should see the number of instances going up. So here I have 1 out of 3, and it's going to create 2 more. And the load balancing in the cluster is just going to send the workloads to the right containers. Okay, so that's the Docker for Mac and Docker for Amazon integration. I think we'll take a break there, maybe 30 minutes. So 70, yeah. Let's take a 30-minute break, and in the next part of the session, first I'll try to make my demo of development work, and then I'm going to tell you about Docker Container as a Service, which is our commercial offering with a role-based access control. I'm also going to tell you a little bit about all the plumbing component that Docker open source recently, and I'm going to tell you about SwarmKit, which is the kit, the component that was developed and that was open source last month in order to develop Docker for Azure and Docker for Amazon. So let's take a 30-minute break now. Before the break, maybe I can answer questions because I'm the only one talking here. So. Yeah. Okay, so the question here is you're using Docker Compose, you launch a bunch of containers, you close your laptop. When you open your laptop back, the time in the containers is still the time when you close your laptop. I'm not sure about that. What I think is that in Docker for Mac, when you wake up when you reopen your laptop, Docker for Mac knows that the time is notified that there's a new time in there, and then resyncs the VM to the right time. Whether the containers that are inside it get that, I'm not sure. Yeah, so yeah. Did you try with the latest Docker for Mac? Okay. Yeah, I didn't try that, so I'm not sure.
Second question. So many of our customers ask us to deploy this. We often deploy our software on closed intranets. I was wondering if we are choosing like dev as a packaging format, or as a specification of how our software should be deployed in a swarm, for example. Is there any way to somehow move, actually deliver the images, Docker images on a closed intranet?
Oh, yes. So the question is, are there ways to deploy Docker images that are constrained inside of an intranet? And yes, there are definitely many different ways. The simplest one is to take the Docker open source registry and to run it inside of your intranet. And when you're building your images, you can push them to the hub, but you can also push them to an internal registry. So you just do a push to that registry, and from Swarm, you just pull the images from that registry. So that's one way. The other way is that there are tons of commercial products. We're making one that's called Docker Trusted Registry that's really designed for that kind of use cases. But there are others that work as well.
There's a dilemma, I think, is kind of a chicken and the egg problem, because in order to build my image, which I can put on a private Docker registry, I need to pull one from the public one, but all customers won't have access to, see what I mean?
Yeah. So the problem that's exposed here is the chicken and egg problem. When you're using a private registry, how do you get your base images? And the answer here is, so we have Docker Store that hosts all the official images, especially for commercial software. So typically the workflow would be a sysadmin that has external access picks from Docker Store the images that they will allow their developers to use. He pulls them internally, then pushes them to the private registry, and then developers access only the private registry and the base images that the sysadmin has determined they can use. Yeah, in addition to that, like, yeah, I'll talk about that in the next session, but there's in Docker Trusted Registry, there's a whole lot of options. For example, you can have your images scanned automatically for vulnerabilities and things like that. And there's role-based access control, and I mean, the whole product is designed for that use case. Any other questions? Okay, let's take a 30 minutes break and see you back at 3:25. Okay, let's get started again. So I didn't have any luck into fixing that demo. But following one of the questions about how to do debugging. So one of you came to ask how do I do debugging with a regular IDE, and actually I have a demo for that as well, and this is documented. So the demo I wanted to make here, you're starting the IDE inside of a container. It uses X. It has your local file system mounted with the Java source code, and then inside of the IDE you can just press debug, and it's just going to launch your app on port 8080, connect it to Mongo, and then you can debug it directly in the IDE inside of the container. The other way is to just set up a compose file that is starting your application with the right path to the class files that are coming from your IDE in debug mode. So in Spring Boot, there's an option for that, for debug mode. The example I have is with Tomcat, where you set up GSPDA or something like that. And actually, I'm just going to show you that now. So this project, before we go there, a lot of the stuff that I'm showing is available on github.com/chanezon/docker tips. There's another interesting one where the debugging things are exposed. It's called docker/labs. So in docker/labs, if you go to developer tools, you have some labs in Java that Arun built that explains how to set up your environment, build a Docker image for Java. It's using a Wildfly example, an app using Wildfly, and Couchbase, because Arun is working at Couchbase. It explains how to run a single container, multiple containers, and then Java IDEs. That refers to a tutorial that one of my colleagues, Sarah Parefina, wrote for how to set up debugging for Eclipse, IntelliJ, and NetBeans to debug Java applications in a Docker container. So I've set that up. I'm just going to show you the code real quickly for that project. So that project, Java debugging, it has so registration database. So here it's a MySQL container. Let me see. So in my project, I have registration database. That's a MySQL container with a specific data in it. Then there's the registration web server, and this is the interesting one. So the Docker file for this guy is Tomcat 7 on GRE8. And so it's creating Tomcat users, but it's adding the SQL connector to it for that application. And then it's creating a folder, user signups. And here it's setting up a GPDA to open a socket on port 8000. And then it's launching Tomcat with remote debugging. The thing is, in that Docker file, you don't expose port 8000. But then what you do is in your Docker compose.yaml. So there you set up a service with a database. So it's going to use the one in registration database. You set your MySQL password and all that. And then the web server is Tomcat. And there you expose port 8000. So what that will do is that it will start Tomcat. It's going to serve, and the most important aspect is the volume here. So if you're looking at the volume definition, you have .app/target/user signup. So let's go in app. App is where I do my code. So I have my code in there. And when I'm going to create a project in Eclipse for that code, if I compile it, it's going to compile all the class files in target. So what you do is that you mount app target user signup where Eclipse is compiling your classes into the Tomcat web apps directory. So what that will do is that Tomcat is going to effectively serve your app, and every time you recompile something, it's going to change it, and that allows you to debug it on port 8000. So once you've done that, you start this app with a compose file. You do a Docker compose up. So I've done that already. You can see it. You can see it there. Registration web server, registration database. You can see that my registration web server maps port 8000 to 8000 and 8080 to 8080. So that was actually the app that was taking the port before. So if I go to localhost on port 8080, I should be able to see the Tomcat page. All right, that works. The manager app, I forgot the... I think it's admin manager. Oh, do I need that? Okay, I just won't go to the manager. I'll just go to a user sign up. Is it users? Yeah, that's it. So that's my user sign up app that's running. And that app is actually, so what I've done there is, here I have Eclipse this time running on my Mac. And there I have created a user sign-up project, so I just imported the project as a Maven project. And what I've done in order to enable debugging is I created a debug configuration in the run config user sign-up, where I want a connection on localhost on port 8000 for debugging. And so when I do that, I can start debugging. Did I think I have oh, wait a minute. I'm looking at Arun, because I debugged Arun's app as well. I think it's in the user sign-up model that there's a bug. So let me see. Oh, is it big enough? Or let me see. Oh. Oh yeah, that's this guy. Yeah, I have a breakpoint here. So I have a breakpoint on this .password. So I'm just going to sign up. All right. Okay, so I can sign up. Let me see. I'm oops, sorry. Okay, let's say I'm born yesterday. And foobar at foobar.com. So I'm just going to submit that. Yes, I want to do that. And here, boom, I'm in my debugger. Yes. So I want to switch to debug mode, and there I can see I can see my breakpoint. I don't know why I can see my variable. Let's go over it. Yeah, that's it. So there I can see that I've set the password to foobar. And if I go there, I can just say, okay, I understand what's happening here. So I just want to continue, resume, and yeah, okay. So now I can log in with my previously created user, and if I go there, I'm getting the password. And I'm testing if the thing in user.getPassword. And you can see password here is sbone is equal to password, which is foobar. So there's a problem in there. So I'm just continuing. And now, something is wrong, check your password again. So actually, if you go through the whole exercise, you'll see that there's the password is actually ROT13 encoded, and you need to decode it before checking it. We just won't do it here. but that shows you how to, basically if you want to debug your application in a Java container, it's pretty similar to debugging it when you're running it locally. You just debug a remote application that's in your container using Compose for setting up all the environment and mounting a volume where your classes, generated classes are, is the way to go for that. And so there are instructions for, in the labs, if you go up, for Java debugging, you will see that there are instructions for Eclipse, IntelliJ, and NetBeans. Anybody using another IDE than this one that you'd want documented? No, good. Okay. Okay, so let's go back to the presentation. So we talked about that. We talked about DevOps. Talk about the new stuff. Oh yeah, so let's talk about the CAS offering. So at Docker, what we're trying to build in terms of commercial products on top of Docker open source that I have shown before is what we call CAS, Container as a Service. It's kind of a new category between Platform as a Service, which is too high level, and Infrastructure as a Service, which is too low level. What we try to get in CAS is agility, portability, and control. Agility mostly for developers, portability for both dev and ops, and control for the ops to be able to set the right resource limitation, access control for running stuff in production. And the goal of our offering is really to help enterprises manage the whole software supply chain for companies. So what a CAS workflow looks like for build, ship, and run, on the client side you have the Docker tools, Docker for Mac, Docker for Windows or Linux. You're using that to create your applications in form of Docker images. Then you push these Docker images to a registry, and there are lots of different registry services. On the Docker side, we have Hub. So Hub is public. You log into Hub. As part of Docker Cloud, there are now workflow and collaboration services associated to Hub, so you can create repositories for a team, and different person in the team can have different rights. So that's the hosted part. Then there's the open source Docker registry. So as I answered in the question that you asked previously, if you want to run a registry internally, one of the options is to just take the Docker registry code or container. There's a container for that, and I think actually that I'm running it locally here. Registry v2 here. So I'm actually running a registry on port 5000 on my laptop here. So you can run your own registry and push your images to that. So you set up a machine within the firewall for that. On our commercial side, we have a product called Docker Trusted Registry that corresponds to that. And then for running your workloads, either on-prem or in cloud or in hybrid setups, we have something that we call Universal Control Plane that uses swarm mode in order to run your workloads across different types of infrastructure. And then at the bottom of that, what you see there is all the integration points. So we are super well integrated with lots of CI/CD tools. If you search for Jenkins Docker, you'll probably find lots of documentation for the many ways you can integrate Jenkins and Docker. And then Maven is integrated with Docker as well. So in Maven, you can build your images and push your images to registry as part of the build steps. And then there's like all the plugins for networking, volume, configuration management, logging, and monitoring. Monitoring, one of the monitoring tool that seems to get more and more traction is called Prometheus. Last month, we had the Distributed Computing Summit in Berlin. That was an invitation-only event with some developers of some of the most popular open source projects. So between the Docker engineering team and some of the Docker captains and some of the distributed computing projects. So the Prometheus team was there, and there's been a workshop for how to integrate Docker and Prometheus. And it seems that I've seen the first pull request in that area already. One of the things that I learned that day is it's pretty easy to run Prometheus either on your Swarm cluster today or even locally. So here, after last month, I just used a compose file that Julius created, the Prometheus creator, that launches everything that you need to have Prometheus and Grafana. So here I have Prometheus Alert Manager, Prometheus itself, the node exporter, and cAdvisor and Grafana. And the result of that is a full monitoring stack for your container running locally. So here, if I go to localhost on port 3000, I think. I don't remember my login, though. Does someone know the Grafana default login? Blah, 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 blah. Oh, give me a break. I don't know. So I won't be able to show you because I don't remember what I've put for login in there. Maybe doing a Docker inspect of this guy. Maybe I have an environment variable somewhere. Oh, here you change me. How original. Okay, so I'm just going back to that, and it's admin and change me. Boom. And here, so what I've done there is that I launched all these Prometheus and node exporter containers, and then set up the default views in Grafana for these. So for example, you can monitor your container host. And so you should have CPU usage and IO usage and things like that. You can monitor Docker containers. Here I don't see much. I don't know if it's still active or not. Or you can monitor Prometheus itself or Nginx. Yeah, it seems one of the containers must be dead because maybe I should restart them. So it's in prom. Yeah, but I forgot where I've put that compose file. So I'll just switch to the other. Oh yeah, we are talking about monitoring. So that's the CAS workflow for build, ship, and run. And that's what it looks like in terms of product. You have any kind of infrastructure at the bottom, the plugins and integration plus Docker Engine on top, and then tools for build, shipping, and running. And Docker Cloud as kind of additional services for collaboration. And then there's a universal control plane. So Docker Data Center has role-based access control and LDAP integration. And there's a pretty rich permission model in there where you can either have no access or you have view only for people who can just inspect containers, but that's it. They cannot touch anything. At DockerCon, the demo was with our... I think it was our CFO who came on, or even our CEO who came on stage, and they gave him only view access because they didn't want him to mess with their containers. Restricted control is what you would give a typical team. So a team can create, run, restart, stop, and delete their own containers, but don't see the containers of other teams. Then for sysadmins who manage the whole cluster. They have full control. They can manage all the containers. And then you have one admin who can manage users and permissions. And so I can show you what this looks like in, or maybe I'll talk and then I'll show you. The latest versions are Docker UCP 1.1 and DTR 2.0. So these are the production versions that are available. But I think right now there's a beta of UCP 2.0. And that's what I'll show you. I'm just using for the demo the nightly builds deployed on top of Docker for AWS. So in UCP 1.1 and DTR 2.0, they added HA, unified authentication between Docker Trusted Registry and UCP. The ability to do compose deployments directly in the UI. So you just paste your compose file and you can deploy it. And a user interface to add new nodes to the swarm. What's new in the beta for UCP 2.0 is that now it's based on Docker 1.12 and swarm mode, so you can do a Docker deploy like I showed you before. Another thing that's pretty new is security scanning in Docker Cloud. So that's been out there in beta for a few months already. And what this does is that it's an optional service that you can elect for your images. I think you have to pay for it at a certain, I'm not sure about that, after a certain number. But what you're doing is that when you push an image, it's going to scan it for known vulnerabilities coming from a database of vulnerabilities and notify you. But the interesting aspect is that as the vulnerabilities are updated, it constantly scans your images. So when there are new vulnerabilities, all your images that are affected, you'll be notified about them, and then it's quite easy to just rebuild them by fixing them and then pushing them automatically in production. So it makes it much easier to solve vulnerability issues in deployed software. That's available only in Docker Cloud today. We're working on a version of Docker Data Center, UCP and DTR, that includes security scanning on-premise as well. But this is not out yet. So let me show you a demo of Docker Data Center. Here I'm logged in. Where am I? Oh, yeah, here. So that's the universal control plane dashboard. And what I can see there is that I'm admin, so I can see all the nodes in so I have one manager and 2 workers. I can see all the services, the containers that are running, and I can manage users and teams, add nodes and configure Docker Content Trust. When I go to resources, I can see my services. I can create a service here. And I can enter all the parameters. And that's the equivalent of a Docker service create. I can also create containers. That's the equivalent of doing a Docker run. Or here I can manage containers. I can see the ones that are up there. I can have access to the logs. I can ask for a console. I can run a shell directly inside of a container from the UI. Oops. To see what's happening or run some stuff. I can see some stats if it's set up. Look at the logs. So basically this is where you can control your containers. Here I can look at all the images that are present in my system. Here I can take a look at the nodes and see whether they're healthy or not, add them. Here I can look at all the networks that have been created with Docker Network Creates. Here I can manage my volumes, and there I can manage my application. And applications, I manage them with either deploying a compose.yaml or from the client, just doing a Docker deploy on a service. But here, what you see is that I'm admin, so I can see everything from everybody. So let's create a user. I create a user path. I'm going to use my favorite password. I'm not UCP admin, and I'm going to give me, I don't know, restricted control access rights. Huh. Okay, so restricted control. So now if I take that and I create an incognito window, and here I'm going to log in as Pat. There I can do much less things. So here I'm going to log in as Pat. I hope I remember the password. All right, I'm logged in. So here you can see I can still see the nodes and services, but when I go to resources and I look at containers, boom, I don't see anything because I haven't created one yet. Images, I can see them. Networks, I cannot see anything because I haven't created any of these. And so the way you use the client to create containers is you go to your profile, and there you can say create a client bundle. And what it's going to do is going to create that zip file. And if I go in the zip file, what you can see there is that I have it generated some certificates for me. And what's interesting is that env.sh. Yeah, basically if I put that directory somewhere, I cd into it and I source this, it's going to set up my Docker client to talk to the UCP host and identify me with over SSL and identify me with the right certificates, the Docker cert path here, with the right certificates that it gave me, and so the access control can be enforced at that level. So I've done that already for the admin user. So let me go in a different directory, and here I'm going to, so I have a little alias, dmu UCP. When I do that, I just source the env file. So if I do env pipe grep docker, you can see here that I'm targeting the nightly instance that we were talking about. TLS verify equals 1 and the certs are in there. So when I do a docker node ls, now I should see that I'm targeting the swarm on AWS that's running DDC in there. And so if I do a docker ps in there, I can see everything. Now I'm just going to go to the other window. I'm going to pat user, I'm going to create a client bundle, UCP bundle pat, I'm just going to expand it, and I'm going to go to downloads, UCP bundle pat, and I'm going to source of.sh. I'm checking that I have. So here I'm using the path that are in the certs that are in there. So here, if I do a docker node ls, I should still see that I'm targeting the right cluster in there. But when I do a docker ps, nothing. So let's create a service demo2. Demo2. I'm going to expose 8080 or let's say 8090. Map it to 8080, and I'm going to launch ehaslet. I always forget how how it's called. Do I have it running in there? It's ehaslet demo or ehaslet docker demo. Yeah, docker dash demo. Oops. Oh yeah, it was there. Docker dash demo. And I'm just going to do maybe 10 replicas. Okay, so that should boom. Oh, what did I do wrong? Docker service create. Okay. Oh, what did I do? Oh, dash replicas. Okay, so if I do a docker ps, you can see all my ehaslet containers. If I do a docker service ls, I see only the service that I have created, and here I created it as pat. And when I go there, if I go to my resources dashboard and I go to services, I can see my my service there, and I can see it's been created. Now, if I remember, there's so this is UCP Universal Control Plane 2.0. I think it's 2.0. Let me see. Running on yeah, it's 2.0. It's running on Docker for AWS. That's set up the same way with an external load balancer. So if I go to my services in there, it should give me a URL where it's exposed. No, so I think it's exposed on a different URL. Oh, that's it. Blah, 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 blah. Okay. So that's the host name of the load balancer for that UCP cluster. And if I go there, hopefully I should see the service that I just deployed. Here you go. And when I go in there, I can see that in terms of scheduling, it's replicated to 10, but I could change that here. I can say, oh, I want only 5 replicas now. Yeah, that's fine. So I just save that. So I just can change any of the arguments of the service, and I can look at the tasks that have been generated. So tasks for a service are the number of containers that correspond to this service. So now I have only 5, and for each of them I can look at I can have a console on them, or I can look at the logs if they were available. Okay. But just to show you that I can see only the containers that I have created, while if I'm the admin here, basically I can see all the containers that everybody has created, the ones there, but also the other ones. So that's Universal Control Plane in short. Now I wanted to talk a little bit about plumbing. So Docker has been very successful in the past few years. So that's a graphic of the number of pools in Docker Hub. So after the first year, it went to 1 million pools in 2014, and people at Docker are super excited. Wow, 1 million pools, it's really success. Just 1 year later, we were at 1 billion pools, and like 2 months ago, it was 6 billion pulls. So there's lots of people using Docker. And this graph just shows all the plumbing that we created out of the Docker project, out of the Docker platform along the way. And so Solomon Heights, Docker founder, gave a very good talk at LinuxCon. I think the video is available, about the open source at Docker. And basically what he explained is that, and that was like last month in Berlin. What he explained is that Docker is learned a lot from Linux, and it adopted the same model but with a twist. And the twist is that at Docker we are more like Apple or Facebook. We start with a finished product and then we open source different components, or we extract different components that people can use independently. So when Docker started, it was like a monolithic daemon with everything in it. Over the past 3 years, it's been refactored a lot to extract different components, and these are the components that we're talking about. So in 0.9, pluggable execution was introduced here in 2015. 2014, and then the libcontainer project was created out of that. Then multi-host networking in 1.7 and libnetwork was created. 1.8 introduced Docker Content Trust and the component you can use outside with curl.pipe.sh, for example, is called Notary. And then runc was introduced on containerd, and containerd and runc are what run container today in Docker. Later, we open source HyperKit, VPNKit, and DataKit that are parts of Docker for Mac. All the network translation, and that's part of VPNKit. The creation of the VM on the Mac, that's HyperKit. And then SwarmKit is the orchestration framework that implements services and tasks. So Notary is a separate piece of software that you can use by yourself outside of Docker to check that what you want to run is exactly what you were expecting, especially when you're getting it over the network. And Notary is built on a framework that's called TUF, the update framework, that is pretty strong in terms of giving you the ability to revoke keys for people who are signing. runc, so it's the Universal Container Runtime. I think Phil Estes from IBM, who's part of the runc committers, is giving a talk about that later this week. So runc is kind of the heart of Docker. I think we have some time. Maybe I can show you what it looks like. I must have a VM with it running somewhere. Yeah, it's on Ubuntu. I hope I remember my password. All right. Wow. Feeling lucky today. So where am I? Okay, so runc, the way it works. Let me make that a little bit bigger, because come on, because that won't be very helpful. Okay. So the way runc works is that you give... so Docker is doing a lot of things. It lets you pull images, build images, push images to a registry, run images. Runc just runs images. So what you need to provide it is a root file system where you have the interior, the inside of your container, what you want to be in your container, and then a file called config.json, and config.json is standardized as part of the Open Container Initiative standardization efforts. So OCI defines the fields that are valid in a config.json to configure the isolation of your container. So let's take a look. If I look at rootfs, you see I have this is a busybox distribution. What I did in order to create that is that I did a Docker run on busybox, and then I exported the file system onto my local file system. And then if I go to config.json, here you take a look at what OCI looks like. So here I specify the version of OCI that I'm running, the platform on which I'm running, some things about the process that's going to run, like here is going to have a terminal. I can specify the UID and GID of the user that's going to run inside, the arguments, the environment variable, and all the capabilities. So here I can remove or add capabilities to my container. I can set some limits. I can specify whether it's read-only or not. And so the result of that, once I've done all that, is I can just say run. So I say run with a name. So I need sudo access here. I think I have forgotten. Yeah, here you go. And there, now I'm in the container. So you can see there's nothing running except that shell. I am user 1000. And if I do ls, I can see my file system. And if I touch bar and I exit, if I do ls minus la of rootfs, I can see the bar file that I have created before. So runc is well so one of the criticism against Docker very often is that it doesn't marry well with systemd. Runc works really well with systemd. So if some aspects of Docker don't give you enough control, or if you want to push the limit a little bit in terms of capabilities, runc is a pretty good option to take a look at. Oh no, I don't want to search. So let me just go back to there, and I'll just quit that VM. Okay, so that was runc. Then containerd. So containerd is a daemon that controls runc. It's built for performance, and that's what Docker is using to create containers. Essentially, it's a daemon written in Go that exposes a gRPC interface to control the daemon. And the kind of calls that you can make to that daemon is to create a container, update one, send it a signal, adding a process into it. Checkpoint and restore, I think, is making its appearances in Docker. I don't want to make a mistake. It's going to make its appearance in Docker pretty soon, but it's already present in runc, for example. And then you can list the checkpoints, get the state and all that. And then containerd is going to call runc behind the scenes. So since Docker 1.11, Docker Engine is using containerd and runc to run containers. So when you look at Docker for Mac, the goal was to make something super simple. I download it, I double-click on it, it installs, and then I have the whale menu, and I don't need to configure anything. The thing is, under the hood, there's lots of stuff going on. So you have a hypervisor, you have a VPN, you have Linux on top of that, so it's an Alpine distribution, and then Container Engine installed on top of that. You need some data services interfaces between the different parts to talk together, and then the hypervisor framework and the VMnet framework needs to be integrated. So the unikernel team, which is part of Docker, and they are very good systems programmer, participated a lot into Docker for Mac and Windows. And they built these kits that implement some of the logic in there. So For example, VPN Kit is that part that does the network translation, and you can use it in your own project. So it's been open source as a separate project so that people can use it in other types of apps. HyperKit is the part that's using hypervisor framework to create the VM instead of using VirtualBox. And DataKit is super interesting. It would require a whole talk in itself. So DataKit is kind of like the Unix pipe, but reinvented for distributed systems. It's based on a distributed database called Ermin that the unikernel team has been working on. That's part of Mirage OS, I think. And this database has, first it's distributed, it has transactions, and it has Git-like semantics to version what's in there. And basically all the components within Docker for Mac are using DataKit to coordinate their actions together. So that's an interesting project in itself to take a look at if you're looking for a cool distributed systems plugin. And the latest that we released is called InfraKit. And so the goal of InfraKit, as I showed you, we have Docker for Mac and then Docker for AWS. Docker for AWS itself is integrated with lots of AWS services. And when we started to build this one plus Docker for Azure, people started asking for Docker for Google, and then there will be other cloud providers. We need a way to manage Docker on different infrastructure in a portable way and in a way that's self-healing. So Docker for AWS looks like something like that. At the bottom, you have all the infrastructure. On top, you have a version of Linux. On top, you have the container engine, your storage plugins and network plugins, the orchestration that's part of Swarm, some admin interface, but then in the middle, you have that infrastructure management piece. And that's what we call InfraKit. And so, I don't have, maybe I'll show you a few more slides on InfraKit. Yeah, I think we have some time. I have another deck on that. Yeah, this one I think is good. I think this one has the details. Yeah, that's it. Yeah, so it's a toolkit, it's a separate project, it's Docker/InfraKit on GitHub, and you can use it today for your own projects. Basically, it's a declarative framework, so you specify your infrastructure with a JSON file, and there you can specify instances and groups. So instances would be VMs, groups are groups of VMs which have certain behavior. It's using encapsulation and composition inside of the JSON in order to be able to have full fidelity for the underlying infrastructure. And the only input for any operation is that configuration. So one of the big differentiator with existing approaches, so if you're looking at infrastructure management systems, there are things like Chef, who are more procedural than declarative. You have things like Puppet, which are declarative as well, Puppet, or there's another one by HashiCorp that's really good. I forgot the name. So there's Ansible, but Ansible is more procedural as well. There's one that's declarative that's called, Terraform, that's it. Yeah, so Terraform is really nice, but it's not active. And what InfraKit brings to the table is this set of active components that are constantly monitoring your infrastructure, and they detect state divergence and they take actions. So that's pretty much the same kind of thing that we did with orchestration of containers with a Swarm kit. It's the same approach but applied to infrastructure. So there's a continuous monitoring and reconciliation of your infrastructure, and there's a notion of rolling updates in there to avoid downtimes. So InfraKit is a toolkit, which means it's a set of primitives to manage collections of resources, to create, scale, and destroy them. There's an abstraction for developers, so groups, instances, and flavors. Flavors are what you install on the instances. For example, you would have a Zookeeper flavor or a Swarm flavor to install Swarm on a cluster. And then it's implemented as a collection of Go executables. So these are Go daemons who talk to each other. But the goal at the end of the day is to implement InfraKit as a set of Docker plugins. So there will be, in a future version of Docker, a Docker infrastructure API that will allow Docker to manage the infrastructure under itself. And the goal would be for a future version of Docker for AWS or Azure is instead of using CloudFormation directly, you just provision an Amazon AMI with Alpine and Docker and the InfraKit plugin for AWS installed. And then you target that Docker engine and you tell it, please generate this a Swarm cluster with 3 masters, 10 nodes on that AWS infrastructure, and then you could manage that dynamically, adding or removing some, or even managing that through the Docker API. So that's kind of the vision of where this is going. But what I find interesting in InfraKit is that it could be used by lots of other projects. It has some to me, it has some similarities in terms of design goals to what Bosch was doing in the Cloud Foundry world. Bosch also had that reconciliation loop, a declarative model, and then constantly reconciling infrastructure. But Bosch was more designed for the VM era, while InfraKit leverages containers to the maximum. So here, what you see there is that InfraKit is using itself. It's using Swarm to manage itself. So InfraKit can manage itself, can bootstrap. So initially, you have a leader, and the cluster config can say, oh, you have an InfraKit leader and 2 standbys. And then when one of them dies, the other one will be leader elected. And we're in the Swarm implementation, we're going to piggyback on the Swarm leader election in order to assign an InfraKit leader. Then after that, you can define 2 types of resources, cattle and pets. Cattle are purely fungible resources. If one dies, you just create another one, and there's nothing special about them, nothing differentiated. Cattle is for systems like typically like Zookeeper, where you need to have an order, specific IP addresses or names. So for cattle, they have they can be stateful. They have a name and they have some state associated to them. So an instance plugin, the kind of methods you have in there is validate the input, provision, destroy, and describe. One thing you don't see here is update. InfraKit is really about immutable infrastructure. So when you want to, for example, move from one version of Docker to another in your Swarm cluster, InfraKit is going to provision new VMs with the new version of Swarm. It's not going to update existing VMs. And then it's going to migrate the data and the live request on it. Flavor plugins, flavors allow you to explain what you want to install on the instances, and group plugin provide the kind of things that you have on how is it called, VM scale sets on Azure and auto-scaling groups on Amazon. There will be some, so with Docker, we want to be ubiquitous and install on any kind of infrastructure, from bare metal to any kind of virtualization on-premise or in the cloud. So our group abstraction will provide the kind of functionality that will, for example, leverage VM scale sets and auto-scaling groups on Amazon and Azure, but on bare metal it will implement its own so that we can benefit from that logic and that kind of features everywhere. So that's what a configuration looks like. Here it's for the Zookeeper example. So here we're using an instance plugin with a Vagrant instance, so that would run locally on an Ubuntu box, and then a flavor plugin with Zookeeper where we pass for the list of IP addresses for the Zookeeper cluster. And then the Zookeeper flavor is a piece of Go that is going to configure the Zookeeper configuration files with information from this and information coming from the instance plugins. And so that's how to run the example in the GitHub repo for setting up a Vagrant cluster of Zookeeper instances locally on your local machine. In the future, I think there's already an AWS InfraKit instance plugin available. So very soon you'll start to be able to use that to deploy to different cloud infrastructure. Yeah, so that's InfraKit. Okay, I think that's all I wanted to cover. One more thing I wanted to add. In terms of resources, and I'll tweet them after the talk. The two main resources are that I showed the examples from during this talk are Docker/labs on GitHub and Chanezon/Docker tips on GitHub. So these are kind of the two places where you have explaining how to debug, how to use X11. Hopefully, I need to debug that to see how it works in reality. And on the Java side, there's one set of exercise that I highly advise you. If you're getting started with Docker and you're coming from a Java background, Arun created this tutorial that had a few bugs, but I sent him a pull request, so it's working pretty well. And it explains in lots of details how to get started, how to schedule one container, building an image, building multiple images, and how to set up Java IDEs and things like that. So that's it. I think we have 2 minutes 30 for Q&A. So any questions? It's been a long afternoon. Okay, no questions. Thank you very much for coming today, and good luck with Docker. It should be a fun thing to get started, and I hope you learned a few tricks for those of you who are using it already. Thanks.